In this video, I will demonstrate a HoloLens prototype of NLign and NCheck. First, I will show how NCheck jobs might be executed on a HoloLens. To begin, I will click on the Execute Job button. A menu is displayed, showing the various actions I can take while executing the job. As you can see, each hole in our test article has a holographic sphere associated with it, corresponding to an NLign named region. The lower left-hand hole is blue, indicating it is the current hole for the activity. Assume that we're performing a bolt hole eddy current inspection and did not find a crack at this hole. I will click the Next Hole button, indicating that this hole is clear. Note that the first sphere has turned green, indicating that there are no discrepancies associated with this hole. The next hole in the job is then highlighted in blue. I find no cracks at this hole as well, and click the Next Hole button. Assume that during inspection of the next hole I detected a crack. First, I will click the New button, and I'm presented with a menu prompting me for which Trendable type to create. Here I will click the Crack button. As you can see, the location of this Trendable has already been populated based upon the selected hole. I'll now enter the crack length and crack orientation on the Trendable form. Now that this discrepancy has been identified, I will click Next Hole. Note that the sphere associated with this hole is now highlighted red, indicating that a discrepancy was found here. I will continue performing the inspection, clicking Next Hole for each clean hole until the next discrepancy is found. Here assume that during the inspection I detected a crack in this hole as well. I will click the New button and again select Crack for the Trendable type. I will then populate the crack length and crack orientation as before. At this point, I will have completed the inspection and will click the Back button. Next, I will show how Trendables can be created on the HoloLens in a more ad hoc manner. First, I will click on the Create Trendable button. I'm immediately presented with the Trendable type selection form. Assume now that I have detected an area of corrosion on the part, so I'll click the Corrosion button. I'm presented with the Trendable form configured for corrosion Trendable types, including fields for the area of corrosion and remaining thickness. Here I am not restricted to creating discrepancies at predefined locations and can click anywhere on the part to identify the 3D location of the discrepancy. Note that the XYZ location for this Trendable has been populated. I will now fill out the details for this corrosion Trendable. Next, let us assume that I have determined a particular hole has been oversized. I will click the New button and then Oversized Hole. I will then click the Select Region button, which will allow me to select any of the hole named regions on the part. Again, note that the location of the Trendable has been populated by selecting the hole. I can now enter in the current diameter of the hole. Once I have added all the Trendables, I will click the Back button. Finally, I will demonstrate how NLign might work on the HoloLens. To begin, I will click on the Overlay Trendables button. Here I can see all the Trendables I have just created, as well as any Trendables that have been created on this part in the past. A menu of various color presets and searches are displayed. First, I will click Color by Type. We can now see that each crack is colored blue, each corrosion Trendable colored green, and oversized holes colored red. Next, I will click the Show Cracks button to see only the cracked Trendables on the part. I will then click the Color by Size button, which will color the cracked Trendables so that the longer the crack is, the more red the Trendable dot will appear. Finally, I can also view all the details about each Trendable. By clicking on one of the Trendables, a form is displayed, showing the detailed Trendable information and XYZ location. Thank you for watching our NLign and NCheck HoloLens prototype demonstration. If you would like to learn more, please visit our website at nlign.com.